Okay, we are live, you guys. This is Chapter 10 test, and I'm just going to go through it with you to maybe help you. I'm not going to do the whole thing, but I'm just going to set you up. So if you want, when you need a copy of it, because everybody needs to do this, let me know and I'll send you a picture of it, either via text, or I can even send it via on the email, okay? And so here we go. Test A, Chapter 10. Skew. Those are lines that don't intersect but aren't parallel, okay? So like this line here, E, and probably this line here, C, would be skew. They're in different planes. They don't intersect. Okay? Pair of perpendicular lines, well, that means it got across at 90. Well, I see a 90-degree ring right there, so probably that one and that one. Parallel lines, well, let's see. These two, the little arrow there, those two might be parallel. Parallel planes, maybe that plane and that plane, A and B, okay? So, okay, 5, find the value of x. Well, those are going to be together. Those are not equal, but sure looks like they make a straight line. So 3x plus 45 equals 180. You can do that. These two are corresponding angles. You see the F. So these are definitely corresponding angles. So I see the F. So they are equal. So I'd say 3x plus 23 equals 4x. And you can solve for x and tell me what the value of x is. Okay. It's a pretty easy test. Okay, here comes some of the, here we go. Name a pair of the following. So 2 and 5, okay? See how they make the C? Okay, 2 and 5 make the C, so there's a name for that. 4 and 5 makes a Z, okay? So you can figure out that we've got that somewhere in our notes. 3 and 6, okay, there's a name for that too. 5 and 8, okay, there's a name for that. 1 and 7, really 1 and 7, interesting. Okay, so these are the names. You've got vertical angles, vertical, you could use vertical angles. You've got alternate, interior, you've got alternate exterior, alternate exterior, you've got your corresponding. We've got our consecutive interior. Okay. Number 12. Are they parallel? Why or not? Well, I think I see the F. So I think maybe I can make a statement about these two lines. And if I see the F, then there's a theorem about why these two are going to make that parallel. 13. I don't know if this is parallel. I mean, this doesn't look very correct, but anyway, take a look at that. 14. What do you know slopes of perpendicular lines? They are negative reciprocals. And if you want to do an example, one slope might be 2/3, and the other slope, its perpendicular slope, be just the opposite, maybe negative 3/2. Okay. Parallel lines have the same slope, right? They're parallel to the same slope. Okay. All right, 16. Here we go. We got a line. We get a point. Okay, so first of all, the slope of the given line. Oh, there it is. I think you guys can see that. Slope. And if it's a perpendicular slope, it would be the opposite. So I'd say, okay, well, what's the opposite of this slope? As a fraction, right? So if you got negative 1/1 would be the opposite of that. So the equation. Let's see if we can draw this line. So if I draw this line in right here, with the equation of this line, y equals some mx plus b. We know the slope is up 1/1, up 1/1, up 1/1, right? And it crosses through here at this point right here. So you should be able to get the equation of that line. Solution of the simultaneous equation, they intersect right here. So what's that point? That is the point. That's where they intersect. That's the solution of simultaneous equations. And then what's the distance? I want the distance. What's this length? Call that A and call that B. So you've got point A, which would be at -1, -2, and point B, which is going to be at 2, 1. Remember, big square root. How do you find the distance formula? You're going to use big distance is equal to big square root, and you've got x2 minus x1 squared plus y2 minus y1 squared, and you got x1 y1, x2, y2, and plug them into the distance formula to get it, okay? Now the extra, okay, how do you find the area of a triangle? The area of a triangle, is going to be 1/2 its base. Okay, so let's check this out, times its height. So if you want to do the extra, it takes a little bit of work, but you can do it. Here's the base. You need to find that length. Here's the base. Here's the height of the triangle. Don't be tricked. Here's the height of the triangle, okay? So you need that length times that length divided by 2. You have to use the distance formula, okay? And then take half of that, okay? So there's the test. When you want a copy of it, let me know and I'll send it to you, okay? That's it. It's easy.